Hello, Bridge. How are you doing? Hopefully great. We're going to take some formal notes. Some of this is probably going to be a review and you know how to do it, but here's some formal notes on distributive property and factoring. So basically the distributive property, when you look at the word distribute, it means to divide something or give a share or a part of something to everything. And basically what it is you're allowing the number on the outside of the parentheses, you're giving it to each of the add-ins, each of these terms on the inside of the parentheses. So basically, again, I know you've seen this before, but you've got that A, you multiply it to the B, that A is also going to get multiplied to the C. So either of these are appropriate examples. Again, A, B, and C could be any number, so either of these are appropriate examples that you should probably get down just a quick little bit right there in your notes for what the distributive property actually means, all right? So again, A gets multiplied to the B, so I have AB. A gets multiplied to the C, so I have A times C. Again, since it's positive, it's an addition right here, these two terms are separated by addition as well. Same thing with that other side. Now the A is just on the other side. All right, so A times C, or C times A, and then we've got that A times the B again, we see right here. So it gives us the same property, same idea, all right? Distributive property. And this is a way that we could also write equivalent expressions. Equivalent expressions are basically expressions that are equal. So these two, AB plus AC and A times B plus C, these two expressions would be equivalent to each other. Okay, so there's the way that I just taught you right now, which is just take the number, multiply it to both of the terms on the inside. But if that doesn't click with you, I'm going to also show you the area model, all right? So again, this is the way I like to do by just literally drawing arrows so I don't forget which ones I multiplied by. So with this expression, 3 times 2 would give me 6. 3 times 5 would give me 15. Adding them together gives me 21, all right? I got a little excited on that 21. The area model is also going to give you 21, but it's going to give you a visual representation of it, all right? So you remember how to find area of a square, which was just base times height? So let's do the same thing. Let's say that you've got a height of 3, and here you've got two things that are being added together. So let's say that this is going to represent the entire width, all right, or the entire base. So let's say that this is 2, this length on your rectangle is 2, and this length is 5, all right? So if I wanted to find the area of this entire thing, this entire rectangle, if I found the area of this smaller one and added it to the area of this one here, I should get the area of the entire thing. So what's the area of this guy? This is 2 times 3, all right? Those are the dimensions, 2 times 3, which gives me 6. The area of this one here is going to be a height of 3, a base of 5, so 3 times 5 is 15. All right, so those are the two areas. Adding those areas together, 6 plus 15 gives me an entire area of 21. So you get the same thing, but if you like to think about it in terms of area of a square, that's totally fine. If you understand this, fantastic. You should also be able to understand this as well, all right? If you need this and you don't understand that, then do that, that's fine. I got one more example here. One more example with the area model. So again, now I'm throwing in variables. Just multiply 5 and x is going to give me 5x plus 5 times 2 gives me 10. Let's see if we get the same expression with our area model. Let's just pick 5 to be our height. And since this is already broken up, let's let this part equal, I'm going to let that part equal 2, and this unknown part equal x. All right, finding the area of these two smaller rectangles so I can find the area of the entire thing. This part, 2 times 5, gives me an area of 10 units squared. And then here, 5 times x gives me 5x. Again, that's the height times the base. And then adding these together to give me the entire, adding these together to give me the entire area is going to be 10 plus 5x, which is the same expression that we got using just our little arrows, all right? Okay, so real quick, let's just go through more examples. They're going to get a little bit harder as we go. So this one, I'm just going to use the arrows for now. If you need to do the area model, please feel free to do that as well. So I've got 7 times x plus 7 times 4 is going to give me 28. Boom, equivalent expression, check mark. This guy over here, I have 2 on the outside and I have a lot of terms on the inside. Just because it's more than 2 doesn't mean I can't do anything. I can still take that 2, multiply it to everything on the inside. So 2 times x, 2x, plus 2 times y, 2y. 2 times a negative z. If you want to think about it, negative z is the same thing as negative 1 times z, right? So I'm really doing 2 times negative 1, all right? So that's going to give me negative 2z. And then that last one, 2 times 4x is going to give me 8x. All right, we could say we're done, or we could even just take it a step further and simplify anything we can in here. Are there any like terms that I can combine? Well, there's x, there's y, there's z, there's another x. So adding 8x and 2x gives me 10x plus 2y minus 2z. All right, so that would be a way that you can simplify that one. This last one here, I have a variable on the outside of the parentheses. Same steps, just multiply your variable to every term. So this is going to be m times 5m. All right, m times 5 is not really going to do anything. But if I have m times m, that's the same thing as m squared. All right, so x times x is equal to x squared. This may be a note you want to get down in the margins of your notebook. And the difference between x squared and 2x is x plus x equals 2x. X times x equals x squared, all right? So since I have m being multiplied by another m, I could say 5m squared. Okay, that was the first term. The second term, m times negative 7n. Nothing special about that, so it's a negative 7nm. All right, just now we have 3 things that are being multiplied together. The 7, the n, and the m. All right, pause if you need to. All right, take a second, read through this little thing. We're just going to be able to write different expressions. So a volleyball team uniform costs $D. Again, D is a variable. I don't know how much it costs, but let's just let it be D. For the shirt, it costs K dollars. I'm going to start underlining these variables that we have. K dollars for the pants and F dollars for the shoes. Write an expression that represents the cost of one uniform. So again, we've got this information that the uniform is the shirt, the pants, the shoes. So all together, that would give us the cost of one uniform. All together, keyword, all together, right? Adding them all together. So D plus K plus F would give me the cost of one uniform, just adding all of my variables together. It says there are 12 people on the team. Use the distributive property to write an expression. And actually, we're going to write two different expressions, excuse me. So 12 people on the team. I'm going to use distributive property and say I'm going to have 12 groups of D plus K plus F. So in parentheses, 12 times d plus k plus f. If I wanted to use the distributive property on this, I could write an equivalent expression to say, all right, 12 times d plus 12 times k plus 12 times f. All right, so again, two different ways to write the same thing. Maybe, I mean, this is kind of like what I think about it. Maybe in this one, you're given the price of one uniform and you just got to multiply it by 12. Or here, you're given the price separately. So you only know the price of the shirt, multiply that by 12, you know you're gonna have to order 12. You only know the price of the pants, multiply those by 12, right? And then finally, a week later, you finally know the price of the shoes, multiply that by 12 and add together. Two different ways to think about this, okay? Next part, so pause if you need to. Next part we're gonna talk about is factoring, all right? So factoring, basically I want you to think of it undoes the distributive property. So basically kind of just some basic steps for how to factor. Look at the greatest common factor between all the terms and pull it out, take it out. So here, again, this is what we had when we did distributive property and we went to this. Factoring is gonna go backwards. So I'm gonna give you something that looks like this. It's already been distributed out, now undistribute it. So when I'm saying greatest common factor, again, factor is something that you're multiplying. 2 times 3 equals 6. Your factors are 2 and 3. Your product is 6, right? So your greatest common factor between these two terms, again, common, the one that you have, I don't know how to make that simple, the one that you have in common with, right? The same one in here. So here my greatest common factor would be A. In both of these terms, AB and AC, the only one that I have in common is A. So that tells me that I can pull A out of both of these and say, all right, let's take A out of here, and in parentheses, what's left is B plus C. Again, maybe you need to get a sketch of that down if you need. Pause if you need to. So let's go through some examples because I feel like factoring is the one that tricks us up the most. Let's start off easy here. 2A plus 6. It's an expression. Let's look at the common factors. So I'm going to do something a little bit here that says I can break 6 down into 2 factors. I know the example that I used right before. 2 times 3 is 6, right? So I can break 6 down into 2 times 3. So if I did that, I would have 2A plus 2 times 3. In here, what is my greatest common factor? I have a 2, an A, and I have a 2 and a 3, so 2 would be my greatest common factor. If I had to pull 2 out, if I had to factor out a 2 from here, think about like dividing both of your terms by 2. So I pulled that out. What's left in the parentheses? A plus 3. All right, so this is how you would factor out that expression fully. 12 plus 36H, okay? Again, if I had to kind of write this out, I could say, what about 3 times 12? Okay, now I see 12 I have in common between both of these terms. So I can pull 12 out of here. What is left on the inside of the parentheses? If I take this first term 12 and I divide it by 12 because I want to pull that factor of 12 out, 12 divided by 12 is just 1, all right? So I'm just left with 1 plus, if I pull 12 out of 36H, that's just going to leave me with the 3 and the H. All right? So that would be a good way that you can break that down. If you can see going from this step to this step without writing out factors, please do so, all right? This guy right here, 4x squared plus x. Again, x squared means I have x times x. So I'm just going to write this out as 4x plus x. Again, it's kind of the same thing here. What are the factors that I have in common? Well, the only thing here is an x, and I've definitely got at least one x on the first term. So if I pulled an x out of this, both of these terms here, or you can think about it as divide both of these terms by x, what's left? I pulled that x out, and I have 4x plus 1. Okay, down here, pretty easy to see. The only thing that I have in common, I've got a 2, and I have h in common, so I can pull out 2h. I'm pulling out two factors now. So 2h can be factored out of that expression. What's left? The g and the p. Up here, only thing, I was gonna make that a little bit harder, but that's fine. I was gonna put a 3 at the top there. A times b plus 9 times b. The only thing in common there is a b. I can pull a b out of this expression, and that would leave me with a plus 9. Last one here, 3m plus 9 times m squared. So looks a little kind of crazy. I'm just going to step it out one more time and say that this is the same thing as 3m plus 9. Actually, 9 can get factored down, right? To be 3 times m. So what do I have in common between this term and this term? That's a 3. I definitely have a 3, and I definitely have m's in both of them, right? So I can take out 3m. So if I pull a 3m out of this expression, what's left? Well, nothing here, it's just 1. If I have 3m and I pull out 3 and m, 3m divided by 3m is just 1. What's left over here? Just 3m plus 3m. If you wanted to check your answer on any of these, all you have to do is use the distributive property. For example, let's do this one right here. To check my answer, let's redistribute the 12. So 12 times 1 is 12, plus 12 times 3h is 36h. Is that the same expression as we did here? Then yes, that one's checked off. If we did this one right here, 3m times 1 plus 3m. Well, 3m times 1 is just 3m, plus 3m times 3m is going to give me 9m squared. I hope you can see that okay on there. It's a little bit light. 3m plus 9m squared. Is that the same expression that we got here? Yes, it is. All right. So factoring and distributive property, you can use each other to check your answers. Okay. Come see me to check off your notes for today. Since it is a Wednesday, there won't be an assignment attached to this, but you need to get this down because we're going to use distributive property all year, all right? But I do want to make sure you were able to take some notes, get some examples down, so come see me at Blackman 107 to check off your notes. Okay, and I got a little meme. Thought this was cute. Hippity hoppity, distributive property, right? Because you would be taking that 2 hippity hoppity. But all right, bye, see you there.